Hello, this tutorial is about how to make a plotter by yourself. First thing, you need to find a set of those guides. Those guides are basically the rails from the recycled printers. As you can see, they just have forming two pairs. And also you need to find a surface that is pretty flat. I just choose a wood board, so that is for my platform. You also need to find 4 pieces of wood that is the same shape, and using the compound saw to cut them into pieces. Eventually, this is the 8 pieces you want. This is to set up the guide rail for the plotter's printing platform, using the press drill to drill the hole for each of them. Now you have 8 pieces and each of with a hole in the middle. On the wood platform, I also using the meters just to measure and draw a sort of perfect, like a rectangular here. The next is to glue my pieces into this wood board. So in this step, don't hesitate to put your rails on it. So basically there's no alignment issue, then everything should be very nicely glued to the base of the wood board. Now they just look like this. In order to make these two rails in parallel, I'm also using the digital scale just to measure the distance between, sliding through the two rails to make sure everything is in parallel. So now they're just is perfect in parallel. So once everything is set up, you need to dry run the size of the platform that is floating on this rail. And if I just put those two little pieces here, and this is the max distance that they can travel. So in my case, I can see this is pretty much like 16 centimeters, and also here is like 16 centimeters. So basically I need to prepare myself at least 16 by 16 square platform so that I can float my this is my base for the plotter. So this is the paperboard I measure as a 7.7 millimeters, which is from the binder, recycled from the binder. It's pretty flat, so I decide to cut this one out with 16 by 16 to use as my base for the plotter. So I use 2 paperboard from the clipper to glue them together to make them more stronger. So this is for my plotted platform, so I put it aside. Now it's the time that we set up everything for the step motor of this the surface. I glue 2 bases here. This is the step motor, which I recycled from one of my printer. This is a puller. I'm going to set up here. This is the rail from the printer as well. So I'm going to put it here. This is another side of the wheel that pulls the belt. Okay. I need to put this one here. And this one it's pullable, so okay, I think this should be good. So the next, I just need to glue everything together. Alright, now this one step motor was mounted to the base. This rail is also mounted. This is the pre-drill hole that I need to fix the rail. Alright. So now the glue is pretty much dry, and also we use two nails. We use two nails at the back to fix the rail on the top. So now it's the time to set up the belt. Before setting up the belt, this is the mounting. So I calculated exactly the height as the same level as this one, as the platform. So I use this piece of wood and using two screws to mount these pieces to the belt. Now it's time just to set it up. Now platform, everything is set it up. We just need to glue all the 5 pieces are on the same level. We just need to glue them together. Now the glue is on, so everything should set up here. Good. Nice and centered. Alright, I can dry run a little bit to see if this one works or not. You see, now everything works perfect. Now it's time to set up the vertical part. It's similar to the horizontal part. We first need to using the compound saw to cut those are standing support. Also use the press drill to pre-drill those holes. And this is the one eventually attached to the your pen, that for the plotter pen. And I also pre-drill a lot of small hole here for the future when I to tie my pen on top of this surface. Now just set it up. Let's dry run and set it up. Make sure everything is aligned. This one is moving freely. So now it's time we need to glue this one to our platform. We just need to do some measurements. Yeah, basically this is the one I'm going to glue this support on. And if you look at it, this one, this is also recycled from the printer, the broken printer. And this is the step motor at the back. And everything is getting modified because most of the recycled printer are using DC motor. They are not using step motor. Those are the step motor I recycled from some other project and reused here. And also I did a lot of cut. You know, you see here, there's a lot of cut here to tailor for my project. And eventually, everything will be set up very nicely, just like this. Now it's time just to glue this one to my surface. So as you can see, I just measure the distance between the top and the bottom, so to make sure they're just in vertical. So I just let it dry up. So next, we just set up this step motor. So I just need to mount the step motor. Now the step motor has been set up, has been mounted to the back. The only thing we are missing right now is this the pen holder that needs to be mounted to the back of this belt. So the belt has been taken off, and this is the back of the pin structure. The pin will be holded here, and so what happens is we need to drill a hole, and using a nail just to mount to this one. Okay, now the belt is successfully mounted to the pin structure. So we just give a test, and you can see this one can move freely without any issue. So I think at this time, once I just lock the 2 pins on the rail, I think that's this part is vertical part is down, and this plus this one. I think the next step, we should go to the computer and set up the circuits to drive everything. So I decided to put an Arduino board and also the shield, the CNC shield at the bottom of this board. And one of the step motor can connect to this, which is Y, sort of easily. A little bit jammed, but I still can connect. But the other one, so looks like I cannot. I need to solder the wire to the X. Let's set up this one, everything in the computer. This is the Arduino. I uploaded the GRBL, the latest 1.1F, from the GHub website. Because this version consumes a lot of memories, and you have to burn your Nano, because right now I'm using the CNC sheet board with the Nano. So you have to burn your Nano to Uno. You can find the instruction on the internet how to burn your flash from the Nano to Uno. The reason why we do this is Nano's flash loader consumes a lot of memory, but instead of Uno contains less. If we reburn the flash to Uno version, that means we can free up some space that can download this 1.1F Gobble program too. But if you're using a Uno with a CNC, you don't have to do this step. So now I just have this 1.1F, so I start to download. Okay, we have done our compile, and now we are uploading the program. Now it's done uploading. Now everything is done. Alright, this is my printer, so everything gets set up. And there's some tricky here, and you have to really understand what are the pairs you have. In order to do that, you have to using your meter to measure which are the pair. If you are interested about this part, you can go search how to find the right pair of your step motor. But after you find the pair, and you just connect to them. So this is my X, and this is my Y, and the next is just to load the GRBL control to test everything to see if it works or not. I'm just loading the laser GRBL version 3.1.2, and in fact any of the GRBL control, doesn't matter if it's laser or not. So I just connected this port, so I get connected, and let's see. Alright, it just returned the version, which is 1.1, in fact is 1.1H. The next one, now everything is active. Now we test X and Y. So I'm pressing the Y right now. Oh, it moves. It moves back. Now it looks like this just one click. It moves too far. I think I need to change the macro steps. This is for Y. Let's see X. I'm just pressing X right now. X. Oh, there's some. Oh, it's same thing. It moves too fast. So I think the same thing. I need to using the micro steps to change it. Okay, now I have all those jumper, as you can see, those yellow jumpers ready. So I'm going to change the macro steps. So I just pull out the A4988. And there's some the jumpers here. So those are the jumpers. Alright, the first one is done. So let's reconnect. And give a test. Oh, now you see this is X. It moves much slower, which is good. Okay, this is the X. There's a little bit sticky there, but I guess once there's a load on it, the pain is maybe it's okay. Let's see. One direction is very smooth. It's the left direction that is a little bit hard. We also need to take out the servo signal. As you can see from my modified Arduino Nagabo program, and I use the D11 to be used as a signal for the servo. So if you look detail here, I just take this pin out, and this pin doesn't go to anywhere in this CNC shield. Instead, it goes to the signal pin of my servo. Another two I just connect with the 5 valve and also the ground, and eventually this one. Right now you can see this is my servo, and we will hook up to my pen structure. This is the pen structure I made. I just using the Lego pieces. It's not that hard. So basically you just need two rail and can slide this the pen holder up and down. And this one I will put a elastic band. So basically this one will also force back to here, and the servo will be at the bottom. And as you can see, this one will be eventually set up like this. The pen will be, the servo is at the bottom to raise the pen or up down the pen. And this structure is much better than the push down. If you have something, there are a lot of people just using push down servo. The push down servo, sometimes when you push it down, it doesn't know how hard you will push down. It always has hard limits. So, but if you have something from the bottom, so this one can just going down according to the surface of this unevenness. Even the surface is very uneven, he still can has a very firm contact, not as a press down. When you press to certain level, he just can't go any further. So now it's time just to mount this one to the back. And I also put as you can see here, I just put the elastic band at the two sides. Now the pen structure will be like this. See, by default it will hold down, but if there's a pen, if there's a servo, he will raise it. So the servo will raise it from here. And as for the pen will be like this, and using this knob, and basically you can lock the pen firmly, so it won't move. So then like this. The servo will be at the bottom. So on the computer side, I just open my laser GRBL, and you can see here I just connected. I just type M5, and also if I type M3, let's say S2000. Alright, this is our servo motor. As you can see, the servo motor was installed at the bottom right now because we're not sure exact location, so we're just using a tape just to dry run everything. So then on the computer, I just keep typing M3 and M5 just to see. See, this is down. As you can see that as you can see, this arm is up. See, the arm is up. Basically, the pen is raised up, and this one is going down. So everything looks like right now this angle and this pen position is correct. So let's give a test of some of the program we have.